Okay, so at the top of the page, this says trigonometric identities. On this page specifically, so I know with the even, odd, cofunction identities, you have some that you had to remember from that packet. For this packet, we're going to have our own set of identities that I want you to keep track of. With a highlighter, if you have one, I would probably box this. This is one set of identities you're going to have to memorize. And who knows, you might already have these memorized. These are called reciprocal identities, all of the ones that are in this orange box. So with reciprocal identities, just pretty simple, because we've been talking about this for weeks. Valeria, what's the reciprocal for sine? What's the reciprocal for sine? Cosecant, CSC of theta, which means that the reciprocal for cosecant would just be sine of theta. What's the reciprocal for cosine, Valeria? Secant, which means that the reciprocal for secant would be cosine. What's the reciprocal for tangent, Valeria? Which means that the reciprocal for cotangent would just be tangent. If you haven't already memorized this, or if you didn't know this, congratulations, you have something you need to memorize. If you already know it, you don't have to memorize it. The two at the end, these are what I'm going to call quotient identities. So these are quotient identities. With quotient identities, we've probably already seen this before. If I asked you to give me the ratio for tangent, Edgar, what would you tell me? What's tangent going to be? Not 1 over. Not 1 over cotangent. It's not on this. Sine over cosine. It's sine of theta over cosine of theta. Flip that around, Edgar. Cosine over sine. That would be for cotangent. Cosine of theta and sine of theta will be for cotangent. If you didn't know both of these, congratulations. You have something else you have to memorize. If you already knew it, you don't have to memorize it. The middle section is the last type of identity we're going to talk about. So I'm going to kind of move it over, and this is still in your unit circle, just for a bit. And in this portion here, your unit circle has a radius of what? 1. Okay, so let me redraw this little triangle that I have. Here's your theta, 90 degrees. This angle here, or this side length, is cosine of theta. This side length is sine of theta. And the radius here is 1. Okay, well, if I asked you to find any side of this triangle, you guys would usually tell me, oh, well, you just need to use the Pythagorean theorem. Well, you're absolutely right. I would use, for instance, a squared plus b squared equals c squared. Okay, well, it doesn't matter which side you label as a. I'm just going to label it as sine, since it's the one closest. So I'm going to say sine theta squared plus cosine theta squared is going to equal c squared, which is your radius, which is 1 squared. What's another way I could rewrite sine theta squared? What's another way I could rewrite sine of theta squared? Say it one more time. It's like I've talked about it already, which I have. When you have sine of some angle squared, you can rewrite it as sine squared x. We did this on the inverse functions packet, very first day. So it's the exact same thing. Does that mean that I could write cosine as cosine squared theta? Yep. And then 1 squared, of course, is 1. This right here is your Pythagorean theorem identity. I feel like I spelled theorem wrong. This is your Pythagorean theorem identity. There's technically 3 equations for the Pythagorean theorem identity. This is just one. If you can at least memorize this one equation, you should be good. If you want to memorize more than one equation, you can. And honestly, I choose to memorize all of the equations at once, just so that way I don't have to worry about trying to recreate them on a test or quiz. But it's up to you. Really quick, if I was to rewrite this as cosine squared theta plus sine squared theta equals 1, is that the exact same thing? Yeah, they're literally the same. Sine and cosine are both still positive. We just switched them around. So this is the exact same. What I have here is the exact same kind of triangle, but I'm just going to double check to make sure that if I had the triangle, for instance, in quadrant 2, if it would give me the exact same formula. So let me go ahead and redraw my triangle really quick. Here's your theta. This is negative cosine theta, so be careful, that's negative. And this is sine of theta. Okay, well, let's think. Here's your 90-degree angle. You would still do a squared plus b squared equals c squared. Okay, well, I'm going to still keep using sine for my a. Sine of theta squared plus cosine. This one is a negative cosine of theta squared, and you're going to make it equal to the radius, which is still 1. Okay, we already talked about this before. Your sine theta squared is already going to be sine squared theta. We've already talked about that. If you're multiplying negative cosine squared, is that going to turn into a positive, or is it going to stay negative? It's going to turn negative, or excuse me, positive. Negative times negative is just a positive cosine squared theta. Notice, this is the exact same thing. This is equal to 1, by the way. Equal to 1. It's the exact same thing as the other one. They're both the same. So no matter what quadrant it's in, it should be the exact same formula. Okay, so like I said, in green, this is the main Pythagorean theorem identity that you definitely want to memorize. There's technically 2 other ones. In part B, over here to the left, let's find the other Pythagorean identity. It says in the directions, if we divide the equation by sine squared x, we get blank. Okay, well, let's take this equation, your Pythagorean identity, and let's divide it by sine squared x. And yeah, what's sine squared x divided by sine squared x? Not a trick question. 1 plus, what's cosine over sine? Look at the top. Is it tangent or cotangent? Cotangent. This is cotangent squared x is equal to, what's 1 over sine? Cosecant. So this is CSC squared x. This is another Pythagorean identity. I personally choose to memorize this. That's just my personal preference. I don't mind memorizing things. But if you don't like to memorize too many things because it'll confuse you, what I would do is just remember the original equation, and then whenever you're on a test or quiz, divide everything by sine. Try to figure out what your last equation is going to look like in the next space. Try to see what your next equation is going to look like. This is the last Pythagorean identity you need. David, if you divide sine over cosine, what do you get? Tangent squared x. What's cosine over cosine? What does that reduce to? 1. And then what's 1 over cosine? Look at the reciprocals at the top. 1 over cosine. That's your last identity. It's up to you guys. If you want to memorize all 3 of these Pythagorean identities that I've highlighted in green, feel free. If you don't like to memorize, keep in mind, this is the one original one, but you have 2 others that follow, when you divide by sine and when you divide by cosine. Okay, so what we're going to do is we're actually going to take the formulas that you guys have, and we're going to put these into use. We're going to use the fundamental identities to simplify your expressions. The fundamental identities are literally the 3 things I've highlighted at the top. These are the reciprocal identities, the quotient identities, and the Pythagorean identities. Hopefully I spelled that right. Those are your 3 identities: reciprocal, quotient, and Pythagorean. We're going to use a combination of sometimes all 3 of these to answer the questions below. I'm not going to do all of these. If it was up to me, I would do all of the questions to give you all of the support you need. But I'm only going to do the ones that I've highlighted in pink. Y'all know how I am. I don't have enough space here. So for me personally, I'm going to flip my paper over to the back side so I can actually do all of the work for this. If you want to flip your paper over as well, you're more than welcome to. So for this question, we need to solve it. I need to try to simplify it somehow. I'll give you this hint before we start going over more things. I'll give you this hint. If you see something that's being squared in your expression, you're definitely going to want to use the Pythagorean identities. Because of all the identities that we have on this page, the only ones that are being squared are the Pythagorean ones. So if we have sine squared theta minus 1, which trig identity should I probably use? Jorge, tell me which one I should probably use if I have sine squared theta minus 1. Well, there's 3 different ones for the Pythagorean. So what? Say it again. The first one, sine squared theta plus cosine squared theta equals 1. The Pythagorean identity that Jorge just told me about, I'm going to write this in my aside space. Aside is just really where I show all of my work to get to my answer. So for aside, I'm going to take sine squared theta plus cosine squared theta, and that's going to equal 1. Jorge, how do I get this equation to look like this expression? What could I do? Say it again. Not quite. It's already equal to 1. I can't make it equal something else. Okay. Okay, let's subtract 1 on each side. So I'll have sine squared theta plus cosine squared theta minus 1 equal to 0, because there's nothing on the other side anymore. Now what? It almost looks like the original problem with the sine squared theta minus 1, but I have the stupid cosine in the middle. How would I move it? Subtract it. So we have sine squared theta minus 1 equals to negative cosine squared theta. Jorge, let me ask you this. Does this part of your equation here match up with the original problem? Yeah, they both match up. So what is cosine squared theta minus 1 equal to? That's it. That's your answer. When you do questions like this, guys, all you're doing is trying to rearrange your Pythagorean, reciprocal, or quotient identities to give you one of the answers. That's all. Your answers for these, which I'll talk about more on the next page, should not be fraction, and they should usually just have one trig function. They should only have one trig function that you have. So, let's look at number 2. This one is secant squared theta minus tangent squared theta. All right, Eurydia, look back on the first page. We had secant squared theta and a tan squared theta. Were they both in the same equation? And if so, what was that equation? Okay, read it out. What is it? Yeah, perfect. This one. On the page that we actually have theta. So is it okay if I replace the x's with theta? Yeah, it's the exact same thing. So on the aside space over here, I'm going to rewrite what she just gave me, which is tangent squared x plus 1 equals secant squared x. Oops, and I said instead of x, we said we were going to put theta. Here's a theta. Here's a theta. All right, Eurydia, how can I get the information that's here for my equation? How can I make that look like this? What would I need to do? And there's several different ways, guys. This is just one way you could do it. Okay, so let's just subtract tangent squared theta on each side. So we're going to be left with 1 equals secant squared theta minus tangent squared theta. Let me ask you this, Eurydia. Does this match with the original problem? Perfect, it does. Secant's first, then tangent. It's negative. That's exactly it. What's your answer going to be if you have secant squared theta minus tangent squared theta? Just 1. This is all you're doing, guys. Next question. I want you guys to try it out. Look back on the first page of this, the front side, and see which of the 3 Pythagorean identities, because I see some things are being squared, which of the 3 Pythagorean identities can you use to simplify it? Chelsea, looking on the first page, which of the Pythagorean identities have the cotangent and cosecant? Say it again. Okay, read it out to me. What does it say? Yep. And instead of x, I just put in a theta, just so that way it's easier for us to kind of see that. Okay, cool. This is exactly what I should use. So now what I need to do, Chelsea, is I need to actually get this equation over here to match up with the expression I have here. What can you do? So Chelsea, you tell me, what could I do to get these two things to match up? What would I need to move first? Okay. And remember, guys, there are plenty of ways that you can do this. This is just one way. So we're going to make this 1 plus cotangent squared theta minus cosecant squared theta equals 0, because there's nothing on the other side. Now what? Subtract the 1. So cotangent squared theta minus cosecant squared theta is going to equal negative 1. Chelsea, does this match up with this? So what can I replace this expression with? What number? Negative 1. That's your answer. All right, last little question before I probably have to flip over to a different page. We have tangent of theta minus secant squared theta over tangent theta. Okay, let's talk about this for a second. I do see something's being squared. I do see that. So I'm probably going to use one of the Pythagorean identities. But the issue is this tangent needs to be a fraction. What is this technically over? 1. If you have a fraction minus another fraction, Gabriel, what do I need? If you have a fraction minus another fraction, what do you need in order to subtract them? Same denominator. So what denominator can we use to make them both the same? That's a secant squared. No, what's the denominator? Tangent of theta. Okay, you need tangent of theta. Okay, so over here, I'm going to multiply a tangent of theta, tangent of theta. I just copied this question, guys, from the front page. All right, so let's see. I'm going to put an equal sign to show you what I did at what time. So I'm going to multiply tangent theta times tangent theta is tangent squared theta over tangent of theta. Gabriel, do I need to multiply anything by the second fraction? No. So we're just going to leave it as secant squared theta over tangent theta. Okay, I have both of these with the same denominator. I'm going to make this into one big fraction. So we have tangent squared theta minus secant squared theta. Gabriel, I think there's something on the first page that has a tangent and a secant, and they're both being squared. Look back on the front page. Is there a Pythagorean identity we can use? And go ahead and read that out to me. What is it? Perfect. All right, Gabriel, you have one last thing to do. How do I make this equation look like the numerator? It's okay. What can I do to this equation to make it match up with this?
Okay, so first you can...
The tangent looks good. It's just a secant. We have tangent squared theta plus 1 minus secant squared theta equals 0. Go ahead.
And then divide both sides by tangent.
Not quite. We already had the tan theta on the right side, right? Tan theta. And we have the secant being subtracted. Do we need this 1? Based on this expression I have here, I don't need that 1. So how can I move the 1? So you're going to be left with tangent squared theta minus secant squared theta equals negative 1. Let me ask you this, Gabriel. Does this match up with the numerator?
Yeah.
Yeah, they're both the same. So what can I replace this numerator with?
Negative 1.
Negative 1.
And so what do you do with the denominator?
That's what I'm about to ask. What can I do now? Not just Gabriel, all of y'all. What can I do? Well, you don't need to divide by both sides. It's literally just an expression. There's not really an equation. I'm just showing you how I'm going from one step to the next. Joseph, what did you say? It's just cotangent. If you look back on the first page, guys, thank you, Gabriel. This is just a reciprocal. 1 over tangent is the same as cotangent. So all I'm going to do on this backside is I'm going to rewrite this as cotangent of theta. But let me ask you this. Is that going to be a positive or negative? Why negative? Because you have a negative here. So just rewrite that as a negative cotangent. That would be your answer. Okay, so for question 6, I'm not going to lie. For all the questions we've done so far, we haven't had an actual angle measure in your parentheses. And that's okay. What we're going to do first is we're going to let theta equal the angle measure of 82 degrees. Just replace it with theta. because I don't know what 82 degrees exactly, but I don't want that to confuse me as I simplify. So since I'm replacing theta with 82 degrees with theta, I'm going to rewrite this as cosine of theta, tangent of theta, all over sine of theta. Really quick, in the numerator, what operation's going on? Multiplication. Okay, keep that in mind. Okay, normally the last couple questions have been really simple. I've just had to really find a squared and then use the Pythagorean identities, but none of the trig functions here are squared. What could I do? Okay, let's separate them. So, Jorge, what would that look like if I separate them? What would the first fraction be? And remember, we're multiplying. Gabriel told us that. By what? Okay, before you guys write that last part out, do me a favor, Jorge. Multiply that across. Cosine times tangent is cosine tangent, right? What's sine times sine? What's sine times sine? Not just sine. Multiply it out, guys. What's sine times sine? Sine squared. That's not the same as this. So you have the right idea, but instead of putting sine in this denominator, what could we put instead? A 1. Let's just put a 1. But you have the right idea, though. Okay. Look back at your first page with your reciprocal quotient identities. Is there anything we can replace? Cotangent with what? The cosine over sine. This is the same as cotangent of theta times tangent of theta. Okay, cool. We've been able to replace that. There's two different trig functions here. There's cotangent and there's tangent. There's a couple of different ways we could write this. Since we know from the first page that cotangent represents 1 over tangent, we could actually replace cotangent again with 1 over tangent. And there's several different ways, guys, you could do this. I've had some students use the quotient identities and replace it that way. I'm going to be a little lazy on this one. Cotangent is the same as 1 over tangent of theta. And we're multiplying it by tangent of theta. Understand, guys, that tangent of theta is over 1. If we were to multiply this straight across, we would get tangent theta over tangent theta. What do you think is going to happen to both of those tangents? They're going to do what? They're going to cancel, which means your answer is going to be what? 1. That's exactly it. I'm going to do one last thing before I write 1. Tangent of 82 degrees, now that I have it completely simplified, and tangent of 82 degrees. It's the exact same number, but when you simplify it, it'll just be 1. I just want you to keep in mind that we initially had the 82 degrees, so make sure you replace that before you finish. In case I did need you to actually compute what tangent of 82 degrees is, I would obviously give you a calculator, or I would tell you to leave it in its tangent form. Give me some nods or shakes so far. Does this make a little bit of sense? All you're doing is you're using the things that you know from other reciprocal, quotient, and Pythagorean identities to help you simplify. Back to the second page, because I actually haven't done this. Okay, so we pretty much finished all the examples I wanted to get to on the first page. We already did all of those. On the second page, a lot of the questions that are going to be left in here are going to be extra practice for you guys. I will say this again in case you don't believe me. If you don't practice this concept, you're not going to do well on your tests and quizzes. You have to practice it. So all of the questions up here, extra practice. The information here I'm going to talk about, and I'm going to do one question at the bottom of this page. Simplifying. With some helpful hints, which we've kind of already talked about a bit. Whenever you're solving or simplifying these, because you're not technically solving, you don't want to have any fractions in your answer. So specifically with your answers, you don't want to have any fractions. And if you notice, for every problem we've solved, we've either had a 1 or we've had a trig function. And it's only been one trig function for our answer. So for both of these, this is in reference to your answers. So your answers should not have fractions, and it should just be one trig function. If you see addition or subtraction with the 1 and or a trig function being squared, that's the first thing I told you on the first page, you're most likely going to use a Pythagorean identity. So PT is a Pythagorean theorem identity. Usually you don't rewrite sine and cosine as reciprocals. Usually. Sometimes you will, but not most of the time. But when you see tangent, cosecant, secant, and cotangent, you definitely want to rewrite those. So rewrite those as many times as possible, because whenever you have sine and cosine, you're able to solve it more easily. The last two bullets are what I'm going to talk about. Factor out a GCF. We're going to talk about that next. We've already kind of talked about a common denominator, but I haven't talked about how to use a conjugate for these questions. So these are the last two things I'm going to talk about. On this page, I'm going to go ahead and look at letter B at the bottom. So down here, let's look at letter B. Okay, so for letter B, this looks disgusting. Okay, let me make this look a little easier for you. Let's say I replace this with 2 times x minus 2. That's the same as 2x minus 2. Ignore the problem. I literally have my finger over it. If I wanted to simplify 2x minus 2, what's the only thing I could really do here? Factor out a 2. I could pull out a 2. So I can make this 2 parentheses. What's left in the parentheses? That's the same thing you're doing here. The only difference is I have a cosine. So you see how you have cosine times sine, and you have a cosine here? We can factor out both of those cosines. So my first step is going to be to factor out your cosine of x and write what's in the parentheses. So Valerie, if I take out the cosine from both of these terms, what's left in the parentheses? Valerie S., sorry. Okay. Minus what? Minus 1. You need something there, so put a 1. Okay, so now Valerie, what should I do? I'll give you a hint. You see something squared, right? Is there a Pythagorean identity that has a sine squared x in it? Look back on the first page. Okay, what's the formula? And is it okay if I just put x instead of theta? Yeah, okay, cool. So now, Valerie, I'm going to bother you, Valerie S. still. How do I get this, or excuse me, this equation to look like this? What would I need to do? Cosine squared. That's cosine squared on both sides. Sorry, I ran out of space. So we're going to have sine squared x equals 1 minus cosine squared x. Okay, it almost looks like this, but I need to move on one other thing. What else do I need to move here? So I'll have sine squared x minus 1 equals negative cosine squared x. So let me just confirm this, Valerie. You match this with this side here, right? What can I replace in that parentheses now? So this is cosine x, and we're going to put in parentheses negative cosine squared x. Not just Valerie, any of you guys. If you have cosine x times negative cosine squared x, what does that equal? Cosine x times negative cosine squared x. Say it again. Cosine cubed. That's exactly it. This is negative cosine cubed x. You're just multiplying them. You have 3 cosines. There's 2 here, 1 here. Multiply all 3. So your answer is just negative cosine cubed x. All right, the last 2 things I'm going to look at. I'm going to do 6a. You guys are going to do 6b. So I can tell you now, for me personally, I don't have enough space here, so I'm going to use the back side of the page. For me personally, my own suggestion for y'all, use the back side of your page. Even if you don't need the space, I'd rather you have it and not use it than need it and not have it. So flip your paper over, write 6a on the back. So before I start asking you guys anything, the first thing I would definitely do, guys, is change this negative in the middle to a plus negative next to sign. The most important thing that you guys will forget is to carry that negative with you. So I'm going to make you keep it by putting it next to secant. It's not going to change any answer. It's not going to mess up anything, but it'll help you with making sure you're doing the right steps. Okay, we have this ugly mess that we need to simplify, and unfortunately none of these are being squared. Okay, so I can't use any of the Pythagorean theorem identities right now. Let's think. Fatima, when you have 2 denominators like this, I need them both to be the same. What could I use to try to get them to have the same denominator? Okay, so what could I do to find a common denominator? Multiply it by what? What do you mean by each other? What would I multiply this fraction by? 1 plus the secant of x. What is that called, guys? It's called your conjugate. This is your conjugate. It's literally just taking the exact same thing. You're just switching the sign. So this is your conjugate for 1 minus secant of x. For this guy here, this will be 1 minus secant of x, because you already have a plus for the second fraction. Be careful here, guys. This is just algebra 1 when we simplify. So when simplifying, let's think. I have my numerator here. We're just going to distribute. 1 times secant, let me rewrite equal, is secant. We're going to multiply secant times secant. What's secant times secant? Secant squared x. This is all going to be over, correct me if I'm wrong, it'll be over the exact same denominator for both fractions, right? Yeah, that's the whole point of multiplying it. So I'm going to move over to the next fraction. We're going to add negative secant times this numerator. Okay, well, negative secant times 1 is negative secant x. Negative secant times negative secant is what? Secant squared x. Positive secant squared x. Let's be honest. You guys and Miss Tapia, we don't want to multiply this out. I definitely don't. What does this look like when you were back in Algebra 1? Or even Algebra 2? Say it one more time. It is a difference of squares. This is just a difference of squares. That's why we went through it in Algebra 2. So with difference of squares, what it states is if you have a squared minus b squared, your two binomials will just be a plus b and a minus b. So Fatima, awesome job. I don't want to have to FOIL all of this out, but I want to use the definition that I have here. What would your a be? Would it be 1 or secant? Let's just use 1. Since it's the first thing, so you just use the 1. So we're just going to do 1 squared minus, what's the b? Secant. Let's do secant squared x. Do I really need to put that 1 squared right here? What's 1 squared, guys? Just 1. So we really don't need that squared, but I want you to see that we could technically write it that way. Give me a nod or shake. Does this make a little bit of sense? We're just relating it back to what you did in Algebra 2. Okay, Jenny, look in your numerator. I'm not going to worry about the denominator for now. Let's just focus in your numerator. Is there anything I can combine or cancel? Because I'm ready to get rid of some stuff. Say it again. This secant here and this secant here. Double check, yeah? Okay, these are gone. Perfect. One's positive, one's negative. We can do that. What about the secant squareds? I can't cancel those. What do I have to do with them? Combine. So what would it combine to? 2 secant squared x. Awesome job. 1 minus secant squared x. Ugh. Fun question. Can I cancel the secants? Oh, thank goodness. No. Joseph, why not? The bottom one is technically, since it's being subtracted, you can't just cancel it. If it was negative 1 or 1 times secant, then yeah, you could totally cancel it. But since it's not, we can't just cancel. Okay, so let's think about this. If I look back on the first page of our notes, we have a secant Pythagorean identity. So let me see if I could replace this and it makes some sense. The numerator, leave it alone for now. There's plenty of ways to do this. We're just going to focus on the denominator. So in the aside portion, I'm going to take tangent squared x plus 1 equals secant squared x. How can I make, ignore the numerator, how can I make the denominator look like this guy here, Jacqueline? How can I make the denominator, or sorry, yeah, this equation look like your denominator? Sorry about that. Okay, so subtract secant, that's what you said, right? Okay, so subtract secant squared x. So we have tangent squared x plus 1 minus secant squared x. And this is all equal to 0. There's plenty of ways to isolate, guys. This is just one way. 1 minus secant squared x equals negative tangent squared x. All right, so let's finish this up. If you notice, the 1 minus secant squared x is the exact same here. So all I'm going to do is just replace that with a negative tangent squared x. So in my denominator, it's going to become negative tangent squared x, and my numerator is going to stay the same. It's going to stay negative 2 secant squared x. I'm almost done with this. I got a lot of things going on, and I know you guys are like, oh, Miss Tapia, we could use the Pythagorean identity again. Yeah, we could, but we're just going to keep going in circles if we do that. So let's do this instead. These are technically fractions. We can split each of them into one big fraction, or one fraction for each term. So I'm going to make this 2 over negative 1 times secant squared x. Secant squared x would technically be over what? And then we'll also have tangent. Oops, and a tangent is in your denominator. So make sure you put 1 over tangent squared x. Take a second to look at it. Odalis, is there anything I could replace with any of these? Because I really want to get rid of some of this stuff. Look back on the first page. Is there anything I can replace? The 2 over negative 1, I'm sorry, it has to stay. Can I replace secant squared x with anything? Look back on the first page. Is there a reciprocal we could use that might be able to replace it for secant? We have 1 over cosine. We could try to replace that because it literally said, and I'm mainly trying to replace that because on the page we were just on, I specifically told you, you usually don't rewrite sine or cosine as their reciprocals, but you will write tan, secant, cosecant, and cotangent. You're definitely going to want to rewrite those, hopefully, as a reciprocal. So on this back side, secant squared x is the same as 1 over cosine squared x. And then keep it on that other page. Odalis, is 1 over tangent the same thing as something else? Say it again. Cotangent squared x. Okay, cool. On that page, before you flip it back, what is cotangent squared x the same as? Look at your quotient. Because cotangent and tangent technically have 2 different things there. What is cotangent the same as? Not 1 over tangent, but what else? This is cosine squared x over sine squared x. What am I trying to set up here? What could I probably do? Cancel. I can finally cancel some things. So let me make this one big fraction. 2 times 1 times cosine over negative 1 times cosine times sine. Negative cosine squared x, sine squared x. Heidi, what can I cancel here? The cosine. Since all of these are being multiplied, guys, I purposely put those multiplication dots so you know we can cancel cosine squared x and cosine squared x. Heidi, what are you left with? You don't have to technically split this up, but since you're learning this, I'm telling you, split this up one last time to make it 2 over negative 1 times 1 over sine squared x. Heidi, why do you think that's important for me to split up? What could you kind of replace? Okay, what can I replace 1 over sine squared x with? Secant. Secant or cosecant? Cosecant. CSC squared x. All you have to do from here, guys, is just simplify. 2 over negative 1 is just negative 2 cosecant squared x. That would be your answer. A lot of these steps, guys, you don't have to keep rewriting. But since you guys are just learning it, I'm showing you each and every step. So when you're doing this on your own, you're not confused. Last question we're going to look at is 6b. So I already know I'm going to need a whole nother piece of paper. So for 6b, I'm going to go ahead and recopy this. And I'll help you guys start this off. Okay, so I see this 1 plus cosine. I had a lot of students last class period get really confused. You do not need to use the conjugate for this. The reason why, the last question on this page, both of the denominators, look at the last question on the last page, they both look the exact same. The only difference was one was negative, the other was positive. For this question, are both of these denominators looking the exact same? No, that's why I'm telling you, you don't need to use the conjugate here. Okay, so we do, however, since we have fractions, need to find a common denominator. What can I do to find a common denominator here? Say it again, Joseph. Okay, so for this first fraction, what do you want to multiply it by? 1 plus cosine x. And then what about for the second one? I'm going to give you this hint before I let you finish. How are you going to multiply this out for the numerator? What do you have to multiply this out using? You have a binomial times a binomial. What do you use? FOIL. Come on. I'm like, don't make this difficult. FOIL. FOIL out this numerator, guys. So I want you guys to start it. Go ahead and start this off. Oh yeah, one last hint. Don't actually distribute these two denominators. Leave them separate because none of them are squared. You can't try to simplify it further. So leave it as 1 plus cotangent times sine. So we said that before you need to FOIL both of these. So 1 times 1 is 1, right? 1 times cosine is cosine x. And cosine times 1 is, again, cosine x. Cosine times cosine is cosine squared x. The denominator for sure is going to be 1 plus cosine x times sine x. I told you guys before I let you guys try it, don't multiply that out because then you're going to get a cosine sine and there's nothing on that first page that will help you with that. The second fraction, you're going to have sine times sine, which is just positive sine squared x. Take a second and look at it, guys. What do you notice? Is there anything I can combine? Is there anything I can try to replace? The cosine x. Okay, so the cosine x here and the cosine x here I can combine. What is that going to turn into, Eurydia? 2 cosine x plus cosine squared x plus sine squared x all over 1 plus cosine x and sine x. This thing at the end is really bothering me. Have we seen this somewhere? Chelsea, where have you seen this? Say it again. On the first page, when you saw sine squared x plus cosine squared x equals 1, you can replace it. So let me ask you this, Chelsea. Does this match up with this? Yeah, even though it's a little out of order, the cosine is positive, the sine is also positive. We can replace all of this with what, Chelsea? A 1. 1 plus 2 cosine, if I could put a cosine first, cosine x plus 1 all over 1 plus cosine x and sine x. I'm going to help you a little bit further, and then I'm going to let you guys finish this. What's 1 plus 1? 2. The numerator here and this denominator almost look the exact same. The only difference is this stupid 2. What can you do with this 2 to try to make the numerator and this part of your denominator match up? Factor. So you guys do this from here. You should be able to finish this. Factor 2 out of your numerator and see what you get. All right, so hopefully you were motivated enough to finish this question, but here's what we have. So after I finished the item in purple, we factored out a 2 from both terms. We factored that out. And luckily, since this 2 is being multiplied by this binomial, and this binomial is being multiplied by sine, we can cancel. Unlike the questions on the other page, those were just having adding and subtracting in the middle. These are actual multiplication, so you can cancel those. Once we have that, we wrote 2 over sine x. And from here, I just split it into 2 different things. Because that sine in the denominator makes me think back to the very first page. When you have sine in the denominator, you can replace it with cosecant, but you usually have a 1 in the numerator. So what I did here was I just replaced 2 over 1 times 1 over sine. And then that 1 over sine I definitely replaced with cosecant. 2 over 1, guys, is just the same thing as 2. So 2 times cosecant of x is what your answer should have been. I will reiterate this yet again. If you do not practice this concept, you will get to your test day and freak out. Make sure that you take the time to do the questions that are left over in this packet, do the questions on your homework to make sure you understand what to do. If you have questions, I need to know.